Okay, well, let's see. Uh, this was a challenging test, right? And we're dealing with inverse functions, which can be tricky. It's saying, what angle has a sine that's equal to negative square root of 3 over 2. And that angle needs to occur between negative pi halves and positive pi halves because we have that one-to-one domain restriction business going on, right? So this is the long leg in a 30, 60, 90 triangle. So when we think about the fourth quadrant, we think about, okay, what if we had a 60-degree angle right there, right? So we put negative, and it does say radians. Why am I doing negative? Because we're going in a clockwise rotation. So from the x-axis, this is a negative rotation. That's a positive rotation, right? And then because we've got 60 degrees, I can't fit 60 degrees in there. I'll just put 60 degrees right over here. That's the same as pi thirds, right? So we're going negative pi thirds, and that's our answer on number one. On number two, it says, what's the tangent? Like you start inside the parentheses, as far as you can go, I guess. I mean, we can look right here, and we just kind of set up above that a negative rotation um, is in this direction, right? So here is 3 pi halves, right? So in the unit circle, if we were right there on the unit circle, that coordinate is 0, 1, right? And tangent is the y over the x. So what this is all equal to right here is 1 divided by 0, which is undefined, right? So we can't take the inverse tangent of something that's undefined. So this whole thing is undefined. All right. Okay. Find the inverse. So when you are finding an inverse, you switch the x and the y. That's the first step, right? So this is our y. Here's our x, obviously. So if we switch those two, we get x is equal to cosine y plus 2. Then there's a plus 1 on the end. Now, when you're solving, you try to undo addition and subtraction first. I know that sounds weird. Please excuse my dear Aunt Sally. Aren't we supposed to do what's inside the parentheses first? Well, we can't. It's buried inside the cosine function. So you pick off the stuff that's on the outside first. In other words, let's subtract 1 from both sides. So we get x minus 1 is equal to the cosine of y plus 2. Now we're to the stuff on the outside of the parentheses. How can we undo a cosine? Well, that's the inverse cosine. That's what an inverse function does. It undoes the other function. So now we've got inverse cosine of x minus 1 equals y plus 2. And now we just have to move the 2 to the other side. And I'm just going to write my answer right up here. So I've got the inverse cosine of x minus 1 minus 2. Okay, so how do we find the domain down here? Because it wants the domain of this function right here. Well, one way to do that is to study, what's the range on this function over here, right? And I don't know that we really need to pay attention to what the domain is. I mean, they're going to restrict the domain, I think in this case, to be over one full period. We can kind of see that we're going a full pi to the right. And let's see, how should we say this? Well, it actually, it isn't a full period, right? Because it would be, a full 2 pi if we went a full period. But if we had the cosine function, we only went half a period. We'd be starting at the top and we'd be going down to the bottom, right? So here we're getting the full range of values. So what is the range on this function? Well, it normally would be from positive 1 down to negative 1. But because we are moving the function up one spot, everything's getting moved up one spot. This becomes 0 right here, because if you move negative 1 up one spot, it goes to 0. And if you move 1 up one spot, it becomes 2. So the range on this function is between 0 and 2. Let me just put that down, including 0 and 2, right? So the domain, when we write our domain down here, we just switch the x, instead of a y there, we get an x. So we're going to go between 0 and 2. All right. That's our domain. Hey, that was a tricky question, you know. So if you missed this domain part, you didn't miss a whole lot of points. I think if you had the function correct right here, but you missed the domain, it was a 5 out of 6, which is a 90%. So that's pretty good. Solve and give the general solution. Okay. So when we solve this, if we divide by 2, we get the inverse cosine of x equals pi halves. Okay. So what is this saying? It's saying what angle has a cosine that's equal to x? Oh, that's pi halves. Okay, so they're telling me the angle over here. So what I could do is I could take the cosine of both sides to get rid of this inverse cosine, right? Because cosine is the inverse of inverse cosine. And what's the cosine of pi halves? That is equal to 0, right? So really what we were saying is in here, what angle has a cosine that's equal to 0? That's pi halves. Okay, so we just found the answer to be 0. Now it does say give the general solution. So, you know, if we were up here and that's pi halves right there, right? It has a coordinate of 0, 1. Well, this one down here has a coordinate of 0, -1, right? So see how the x value is still 0 down here? So what's the angle between these two? Well, it's a full pi, right? So I could put 0 plus pi k. Now, honestly, I didn't grade the general solution part. What I did grade was, did you have 0 right there? Okay, so if you didn't have the general solution part, it's okay. And really, we should say that k represents any integer. K is any integer. Okay, so you could rotate clockwise a pi, or you could rotate negative pi, or negative 50 pi, whatever you want to do. You're going to end up, at one of these two spots, if you just add a quantity of pi. All right, establish the identity. Boy, this one was tricky. You could start with either side, but once you pick a side, you can't jump to the other side and start messing around with the other side. Okay. Our goal is to get the left side to look identical to the right side. So one thing we could do is write cosecant as 1 over sine theta. This is one of the suggestions, is convert everything to sines and cosines. And then what we're going to do is we're going to try to get a common, denominator here. Well, this is sine theta over 1. So I'd have to multiply this one by sine over sine, and it becomes sine squared theta over sine theta. Okay, so now this one has a sine theta for its denominator. We need we already have a sine theta over here for this denominator. So now we can add them together, or it doesn't really look like addition, it looks like subtraction, but we're just going to put the numerators together over that denominator. Okay, so now let's think about that for a second. And sometimes you got to take a peek back at what you're trying to get. Boy, I don't see a cosine over here. And remember cotangent. Now you might say, well, hey, wait, you're messing with the right side. No, I'm just picturing in my head what the cotangent is. The cotangent is cosine theta over sine theta, right? So, gosh, really what I want in the numerator is cosine squared, and I want a sine theta in the denominator. Well, look, I got the sine theta in the denominator. How could I make the numerator cosine squared? Well, we know that sine squared theta plus cosine squared theta equals 1. So if we move a sine squared theta to the other side, cosine squared theta is equal to 1 minus sine squared theta. Okay, 1 minus sine squared theta is cosine squared theta. So right here, I can replace that with cosine squared theta. All right. And now on my left side, I have exactly what I wanted. I wanted a cosine, and I wanted a cosine in the numerator, right? 2 cosines in the numerator. I got that. And I want to sine in the denominator so that I could take this sine and divide it into one of the cosines. So I could put cosine theta over sine theta, and then we'd have it times cosine theta. All right, almost done. Almost done. I'm trying to make it look identical to this, right? Oh, wait, I am there, right? Because this right here is cotangent. So I've got cosine theta times cotangent theta, because this guy right here is cotangent. So check mark. All right, I made it. I proved the left side is identical to the right side. Here's the left side, here's the right side. I just worked my way and made it identical. That was a challenging identity. Wasn't the easiest one that I could have given you. That's for sure. Find the exact value of 13 cosine of 13 pi 12ths. Okay, so this is where you've got to say, I'm going to add two angles together to give me 13 pi 12ths. And the two angles that I want to add together are angles that I know, right? I know something about those angles. So let's think about like, how about 9 pi 12ths plus 4 pi 12ths? Let's just investigate what that is. 9 pi 12ths plus 4 pi 12ths. That would, without a doubt, give me 13 pi 12ths, right? And why am I picking 9 pi 12ths and 4 pi 12ths? Well, they reduce down, right? So they reduce to angles that I'm more familiar with, right? So like 3 goes into both these guys. So I got 3 pi fourths, and I've got over here pi thirds, right? So what I want to do now is I want to find the cosine of two angles added together. I want that formula, right? And excuse me, that formula is cosine of 3 pi fourths times the cosine of pi thirds. And then we subtract the cosine. Oh, no, it's not the cosine. Let me start over here. Sine of 3 pi fourths times the sine of pi thirds. Okay. So let's see here. Where are we now? Yeah, I think I'm doing okay here. So my next step is to, well, you know what we should do is we should confirm that we have the correct formula, right? Like if we choose the wrong formula, and I said we don't have to memorize this. So I'm just checking real quick here. Yeah. Okay, that's why I'm sitting here looking at this guy and I'm going, wait a minute, something's different here. I didn't go all the way up to number 6. I'm doing number 7 first. So here's number 6. I didn't make it all the way to the top. Sorry about that. So if I'm confusing you, like, why is he doing 7? I got myself confused there. Okay, so yeah, I got the correct formula down here. Oh wait. Yeah, I do. I have the correct formula. So what's the cosine of 3 pi fourths? Well, that's I'm in the second quadrant, right? So some people made little drawings for these guys, right? That's not a bad idea. So we have this angle right over here, and you can see that we're going back. So that's negative square root of 2 over 2. And then this guy right here is the cosine of pi thirds. Well, that's that short little leg right over here. That's a half. And then, oh, shoot. And then, I do have a minus there, right? Yeah, that's right. I think that's right. So I got minus, and then the square root of 2 over 2 times the sine of pi thirds is square root of 3 over 2, right? Okay, so what do we end up with here? We end up with negative square root of 2 over 4. And then over here, we end up with minus square root of 6 over 4. And the way I wrote my final answer is I just put everything in the numerator because they both have a 4 in the denominator. All right. Hey, sorry for the hesitation there. That threw me off that I was on number 7 instead of number 6. Let's scroll our way up to number 6. So the same idea, right? We want to think of two angles that add together or subtract to give us 165. The way I thought about it is 120 plus 45. And then what I said was, well, the sine of 120 plus 45 would be equal to the sine of 120 cosine 45 minus, no, this one's a plus right here. This one's a plus, yeah, plus. And then we've got cosine of 120 times the sine of 45, right? Okay, so sine of 120, let's see, that's the square root of 3 over 2. Square root of 3 over 2. Cosine 45, square root of 2 over 2. Square root 2 over 2. And then we've got the cosine of 120, that's negative 1/2. And this guy is the square root of 2 over 2. So all this reduces down to square root of 6 over 4. And this guy has a 4 too in its denominator, right? So let's skip that in between step. And this would be minus square root of 2. And a lot of people had, sign issues. Here you had the square root of 6, you had the square root of 2, but you didn't have a negative there. And kind of the same thing happened down here on number 7. Some sign issues. A lot of people had this, idea here, but they didn't have the correct sign. SIGNs, the negatives and the positives got messed up. So, anyways, hey, what do we do here? This is the kind of problem, and the reason why I had this little drawing here is to remind you to make a drawing. And we're in the first quadrant here. We got 4/5, right? So we've seen that triangle come up a fair amount. If you have a sign that's 4/5, right? So this is 4/5. Then this leg down here is 3/5. That's the cosine, right? And then the hypotenuse is 1. So when we're doing the sine of alpha plus beta, we want to do that formula that we were doing, up above in number, what was it, 6, I think. So we've got the sine of alpha, cosine of beta. Let me write that down. Sine of alpha, cosine beta. And then we've got minus the cosine of alpha, sine beta, right? And so what do we have so far? We have the sine of alpha is 4/5. Okay, so let me put 4/5 right here. And we have the sine of beta. Oh, that's right. We got to make a drawing for for the beta angle. That was our alpha angle, right? This is our alpha angle. Now we're going to make a beta angle. And it is in the second quadrant. So it kind of makes sense for me to focus over here in the second quadrant. And let's just draw the triangle like, let's see, like this maybe. So if we have 5/13 right there, 5/13, this is going to be negative 12/13. I'm getting crammed down here at the bottom of my picture. So this is going to be negative 12/13. How do I know that? It's a 5, 12, 13 triangle. It's just a 13th as big as a 5, 12, 13 because the hypotenuse is 1 instead of 13, right? So when I look at the cosine of beta, here's beta right here. Well, I'm going to put in there for the cosine negative 12/13. This messed some people up. They forgot about the negative coming back this way. Okay, so then what do we got? We got the cosine of alpha. So I look up here and I got 3/5. And then I've got the sine of beta. Sine of beta is 5/13. So we put 5/13 down here, right? Okay, so let me think here. What do I got in my formula? Formula. Oh, yeah. This is a plus sign. My bad. This is a plus sign. Gosh, man, I can never keep straight. I'm not even trying to keep straight. Which one's the plus? Which one's the minus? I just look at the formula. And yeah, this one has a plus in it. So what do we do next? We multiply these two together and we get negative 48 over 65. And we multiply these two together and we get 15 over 65. And then when we subtract, 15 and 48, because this is a negative, we get negative 33 over 65. So like I almost botched the negative sign right here. If you made that negative, then you'd have like negative, 63 over 65. And a lot of people had negative 63 over 65 or positive 63 over 65. And I think I did a -2 for that. Just for, I guess I could have made it a 5 out of 6, but I felt like, part of the challenge here is to keep these triangles straight, and sometimes I wasn't sure if it was a triangle issue, this negative sign, or if it was the formula that caught you off guard, or messed up the signs. I hope that's okay on number 8. All right, here comes number 9, the last one. So what do we need? We need a formula. And the half angle formula for cosine was the square root, plus or minus the square root of 1 plus cosine, right? So So I go like, I'm just going to put it down. 1 plus cosine of alpha all over 2, right? So when I look up above, they wanted me to use the angle up above for alpha. So here's our alpha angle right there. And there's the cosine, 3/5, right? So I go the square root of 1 plus 3/5 divided by 2. Okay, well, 1 is 5/5. So I've got 8/5 divided by 2, right? So I got the square root of 8/5 divided by 2. When you divide a fraction by 2, it cuts the denominator, well, it doubles the denominator. That cuts the fraction in half, right? So now we've got the square root of 8 over 10. All right. And then what I did was to rationalize the denominator, I multiplied the numerator and the denominator by square root of 10, and that gave me the square root of 80 all over 10. And then I said, well, 80 is the same thing as 16 times 5. And so if I go the square root of 16, I pull a 4 out, right? So I've got 4 square root of 5 all over 10. And then I reduce the 4/10 down to 2/5. So I ended up with 2 square root of 5 over 5. 2 square root of 5 over 5. Now you might say, what happened to that? Where's that square, 4 square root of 5 come from? Let me walk it through a little bit slower. So what 80 is 16 times 5, right? And so we can take the square root of the 16, but we can't take the square root of the 5. The square root of 16 is the 4 right there. And then I'm leaving the 5 underneath the square root sign. Okay? Whoo, that was a challenging test. I mean, I'm impressed that, anybody is up near 100%. It's hard to make every single little maneuver. And we had one person get 100%, and then we had some people that were really doggone close. So well done. If you struggled on it, don't beat yourself up too much. We're going to, I'm saying we're doing some corrections right now, and that'll raise your percent up. Thanks for watching my video. Appreciate it.